Hi everyone, how y'all doing? I'm currently down in UTN doing this video, so you guys get my very first one, so we're gonna try to find out, see how it works. I hope you're all doing okay. I do miss you guys for the most part, even Claire, yeah, some days even you. But otherwise, welcome to lesson 6.2, law of cosines. I'm going to try to keep this as short and sweet as possible so that way you guys, when you're watching this video, it's not taking up an entire half hour of your time. So with that being said, we're going to jump right into it. Sorry about the table shaking. This is me just kind of moving around and, well, as you guys know, I like to talk with my hands, so this stand's going to shake. So you're going to have to bear with me. So 6.2, law of cosines. All right, so we still have our triangle set up from the law of sines. You got A opposite of A, B opposite of B, and C opposite of C. That's going to remain the case all the way through. So now the law of cosines can be used to find two different things, okay? It can be used to find a side or used to find an angle. So here's our three formulas for finding a missing side when given two sides and an angle. Here's our different formulas for finding a different angle. Now we will use the law of cosines to help us find a matching pair. So this is useful when we're giving either side, 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 or a side, angle, side information about triangles. The law of sines we use whenever we had a matching pair and then we would make the proportions. Law of cosines is what we use when we don't have that information, but we will use it to try to find one. Okay, so there's three things that we're going to talk about here. First of all, we're going to talk about the two different types of cases. So for our first example here, we're going to do the side, side, side. What we're going to do here in a second, we're going to find all the angles when given A is 8 foot, B is 14 foot, and C is 19 foot. Now I forgot to mention this. At any time you want to pause, go ahead. Obviously my feelings won't be hurt, but I'm not going to go back and repeat stuff. Okay, suggestions. Always find the largest angle first, okay? And use your triangle common sense. The largest angle will always be opposite of the largest side. So looking at our three sides here, A is 8, B is 14, C is 19, I'm going to find C first. That's the one that makes the most sense to do first, okay? So now, don't report me to Kravik. I did steal a marker board so that way I could use it at home. Okay, so I'm going to use the formula for finding the cosine of C first because the information that I'm given is all about the side, so I want to find angle C. So I'm going to use A squared plus B squared minus C squared all divided by 2AB. Now, since I'm trying to find the angle, okay, so we're going to find C. That means we got to take the inverse cosine of all this stuff. Well, A is 8. So we're going to have 8 squared plus 14 squared minus our C squared. So that's going to be 19 squared. And we're going to divide all of that by 2 times A, which in this case is 8, times B, which is 14. Inverse cosine of this is going to give us a number. Round this decimal to the second decimal place. Okay? What I got for this when I did it, I got 116.8 degrees. .80, but it's kind of redundant to write that 0. So now that we've got this, we got 118 or 116.8 for C. Matching pair. I'm going to use that matching pair to help me find B next. Because that's the next largest one. 116.8 is obviously the largest. You can't go any bigger than that on a triangle because then you'd be more than 180 degrees. Now the nice part is, since we got a matching pair, I'm going to go jump right into the law of sines. So I'm going to use the one that I know. So I'm going to have 19 over the sine of 116.8. And that is going to be equal to, since I'm going to find B, I'm going to use the 14 over sine of B. Now, just like what we did to find C, since we are finding an angle, that means I'm going to have to find the inverse sine of, well, now you do your cross products. 14 sine 116.8, and I'm going to divide that by 19. Once you get done, once you do that, you'll find it's 41.12 degrees, and that is our B. So now we have our C, we have our B. The last one we need to find is A. Well, we have 2 out of the 3 angles in a triangle. Again, our triangle common sense. The whole thing adds up to be 180, so I'm going to do 180 minus 116.8 plus 41.12. Well, that's going to give us 22.08, and that's our A. So we got our A, we got our B, we got our C. So right there, we have everything that we need, well, to finish this triangle. So that is the first case, that is the side, side, side. So you start off by finding a matching pair. Typically, you find your largest angle first. Once you have a matching pair, then you go into the law of sines. That'll give us 2 out of the 3 angles. And then to find your last one, bam, 180 minus the 2 angles that we do have. Okay. So next up then, we're going to do side, angle, side. In this case, we are given that A is 25 degrees, B is 9, and C is 12. Okay, so we're given angle A, side B, and side C. If we're looking at it from our triangle perspective, sorry, went the wrong way on that. A, B, C. So we're given angle A is 25 degrees. We're given side B was 9. And side C is 12. Here, I want to find side A here, which means I'm going to use the law of cosines to find the side. So we're going to find A squared. That is equal to B squared plus C squared minus 2BC cosine of A. Means we have to get A by itself using this information. So to get rid of a square, we have to square root the entire thing. So you have A is equal to the square root of all this stuff. B is 9, so we're going to have 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25 degrees. I did all this ahead of time. I have found this to be roughly 5.41. Now this is not degrees, this is the side length. Now think about your triangle common sense. Angle A is probably going to be the smallest side because it's 25 degrees, or angle A is the smallest angle, so that means side A would have to be the smallest side. Okay? So, with that in mind, we're going to go into the law of sines again. And kind of like last time, we're given 2 different options. We can either find the angle C, which goes with 12, or angle B, which goes with 9. Always find the largest one first. Always. So that means we're going to find C. So I'm going to give our matching pair that we know. So we have 5.41 over the sine of A, which is 25. That is equal to 12 over the sine of C. Once again, we're finding an angle, so we're going to do the inverse sine of all this junk. 12 sine 25 over 5.41. B, well, this is one of those interesting cases. I found that to be 69.62. Now, if you kind of think about this here, okay? Remember back with the law of sines, oops, sorry, my hand was in the way. Back in the law of sines, we had the case where there was two different triangle possibilities. And that was the case because there was some, we didn't know if it was always with the larger side, with the smaller side, whatnot. This 69.62 could have a different value as well, because law of sines, there's two different values for the same one. The other one that it could be is 110.38. How I found that? I did 180 minus the 69.62, which gave me that number right there. The reason why this is significant is because if we take this 110.38 plus this 25, if that still gives us a number less than 180, then that means it's a possibility. And 25 plus 110.38 is 135.38. That is less than 180. That means this one's not the possibility because we did this for the largest side. Because if we did this angle here, the 69 plus 25 is roughly 94, which would give us the angle about 80 something for B. Well, that doesn't make sense because side B is shorter than side C. So that means we would have to use this angle right here for our C. 25 degrees. We know C is 110.38. Now all that's left, we have to find B. Well, 180 minus 135.38. That is 44.62. A, 5.41. We got our angle C, 110.38. And we have our angle B, 44.62. Again, when you get to finding this angle right here, just make sure you're double checking. You do 180 minus the angle that you found. If it's a possibility, you got to look at your triangle common sense. Since C is longer than B, that means angle C has to be greater than B. If we did the 69.62, that would not work. But the 110.38 does, therefore B is 44.62. Okay, now we've gotten 2 out of the 3 things done. There's one last thing I want to talk about. Okay, and kind of like before, now area, when using the law of cosines, is actually quite a bit easier. It is completely dependent on knowing all 3 side lengths. You don't have to know any angles. All you need to know are the side lengths, okay? So if we know all the side lengths of a triangle, we can find the area fairly quickly. The area of a triangle is the square root of S times S minus A times S minus B times S minus C. Now you're probably looking at me and like, what the heck does S even mean? Well, S is the sum of the 3 sides all divided by 2. So as long as we know all 3 sides, we take it divided by 2, that will give us our S. Now what I'm going to have you guys do here, we're going to find the area of a triangle where A is 43 meters, B is 53 meters, is 72 meters. Okay. So we have our A, we have our B, we have our C. First thing I'm going to have you guys do, find S. And again, S, Think about it this way. S is equal to the sum of all the sides, so there's your S's, divided by 2. So I'm going to take 43 plus 53 plus 72, and I'm going to divide it all by 2. When you do that, well, that's going to give us 168 over 2. So our S is 84. All right? So now that we have our S, we know our A, we know our B, we know our C. So I'm going to go straight into the formula. Area is equal to, well, S in this case is 84. S minus A, so I'm going to do 84 minus 43, 41, times 84, so S minus B, 84 minus 53, which is 31. And the last one, 84 minus 72, which is 12. Simple. Plug and chug, put it into your calculator, go with it. This is an area. Make sure you have your correct units. It's going to be meters squared. Okay. For a couple of different examples, I want to try to keep this a little bit shorter. I thought I did a pretty good job, so I'm going to get you right to it. The assignment will already be on Google Classroom. If you have not checked that yet, which I don't know why, because you'd have to go there to get to this video, here's your assignment again, okay? I want you guys to have this done by next Monday, so that way I can take a look at it and I can get the information back to you, and I'll have the next one posted up by then. So it's page 413, it's number 5, 8, 10, 11, 14, 23, 37, 40, and 40, 43, and 59. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different questions. I would imagine it'd probably take you guys about an hour if you take your time being diligent with it, so about 6 minutes per question. I don't think that's too terribly bad. By the time you add this, it's about 80 minutes total. So I'm trying to keep it fairly short for you guys. If you have questions, make sure you catch me on Zoom. I posted the times in Classroom. I can help you out. You can send me an email. I'll try to help you out that way. Or if you guys need to get a hold of me some other time, that's perfectly fine. Just let me know and I'll work with you, okay? Otherwise, I hope everybody's doing all right. I do miss you guys for the most part. Who am I kidding? I miss all you guys. To you seniors, I got no word for you. If you're sticking it out, finishing the semester, I really do appreciate it. To you juniors, I better not hear a darn word about senioritis next year, because you guys already know what it could be like. So take care of yourselves, take care of your families. I hope to see you guys as soon as I possibly can. Talk to you guys later.